Welcome to Basic Definite Integral Examples. This is part 7 of our Calculus 1 review and is the last part of our Calculus 1 review. So recall again, if f is continuous on the closed interval AB, and if the derivative of capital F of x is equal to our lowercase f of x, then we get that the definite integral from a to b of lowercase f of x dx is equal to capital F of b minus capital F of a. So for example, let's go ahead and evaluate the definite integral from 0 to 5 of 3x squared minus 2x plus 1 dx. So in this case, this 3x squared minus 2x plus 1 is our lowercase f of x. Our capital F of x, we can go ahead and pick to be, we would do 3x cubed over 3 minus 2x squared over 2 plus x, and then we have our plus c. We can go ahead and just pick that c to be 0. And so we wind up with our capital F of x is just x cubed minus x squared plus x. So we have that the definite integral from 0 to 5 of 3x squared minus 2x plus 1 dx should be equal to, we are going to take our new function x cubed minus x squared plus x and evaluate that at 0 and 5, the bounds of our integral. So we are looking at 5 cubed minus 5 squared plus 5, and then we'll subtract off 0 cubed minus 0 squared plus 0. 5 cubed is 125 minus 5 squared minus 25. We're looking at 100 plus 5 is 105. That remaining part just becomes minus 0. And so we get that our definite integral is equal to 105. For another example, let's go ahead and evaluate the definite integral from pi over 6 to pi over 3 of 5 sine of x dx. Again, this 5 sine of x is acting as our lowercase f of x. We have our capital F of x must be an integral of 5 sine of x dx. The integral of sine is negative cosine. So we wind up with a negative 5 cosine of x plus c. And again, we can go ahead and just pick c equals 0, since we just need an antiderivative. This gives us, therefore, that the definite integral from pi over 6 to pi over 3 of 5 sine of x dx is equal to, we have a negative 5 cosine of x, and we are going to evaluate that from pi over 6 to pi over 3. So we are looking at a negative 5 cosine of pi over 3 minus negative 5 cosine of pi over 6. Cosine of pi over 3 is just 1/2. So we are looking at a negative 5/2, and then plus cosine of pi over 6 is root 3 over 2. So we'll have plus 5 root 3 over 2. So the definite integral from pi over 6 to pi over 3 of 5 sine of x dx as a negative 5/2 plus 5 root 3 over 2. Finally, let's go ahead and evaluate the definite integral from 1 to 9 of 1 over square root x. This 1 over square root x is acting like our lowercase f of x. Our capital F of x should be an integral of 1 over square root x dx, otherwise known as an integral of x to the negative 1/2 dx. That's just a power rule question. So we are looking at negative 1/2 plus 1 goes up to positive 1/2. We have x to the positive 1/2. Then we should divide by that new power of 1/2 plus c. Once again, we'll go ahead and just pick c equals 0. And so we are looking at our f of x is 2x to the 1/2, or 2 times the square root of x. So from here we get, therefore, that our definite integral from 1 to 9 of 1 over the square root of x dx is equal to, we're doing 2 square root of x and evaluating that at 1 and 9 and subtracting our results. So we have 2 times the square root of 9 minus 2 times the square root of 1. This becomes 2 times 3, or 6, minus 2, that are known as 4. So this is using the fundamental theorem of calculus to find basic definite integrals. The next question, which we will investigate in the next videos, is what happens if we don't know an antiderivative? We will look into this in the next video. So we will investigate this in the next videos. From section 5.5. So again, we've covered what we can do if we do know the antiderivatives, if we're using just a basic integral fact. If we don't, we'll have to look into something else. But if we do know our basic integral facts, definite integrals are pretty quick to take with the fundamental theorem of calculus.